this is such a pretty problem. We're not going to actually worry about numbers too much here. We're mostly talking about concepts. And the main concepts are de Moivre's product theorem and quotient theorem. How do you multiply complex numbers together? How do you divide them? And then how do you graph the result on the coordinate plane? So let's take this first one as an example. W squared. Well, here's W. And what I want to do is multiply it by itself. So first I think to myself, okay, well, what's the magnitude of W? What's its modulus? And that's equal to 1. As you can see, this inner circle right here has a radius of 1. So when I multiply W by itself, it's not going to scale it by a multiplicative factor. It's just going to stay at 1. So here are my choices. It's going to be N, R, B, F, or J. See, it's going to be one of these things with a radius of 1. The question is, where is the angle going to go to? So I think about this in terms of the angle of W, right, theta W, and it's squaring, which means multiplying by itself, which means adding its angle to itself. Now this angle is, I don't know, about 240 degrees, maybe a little less. So I'm doing 240 degrees plus 240 degrees, and that equals 480 degrees. And whoops, I'm over a unit circle, right? So we just need to bring this back down using a coterminal angle, subtracting 360 degrees. And what does this get? This sends me to, looks like 120 degrees. So I'm looking for something with a magnitude of 1, a modulus of 1, around 120 degrees, maybe slightly less. And there we go. That's J right here. So that's the procedure you go through. I'll do an example for Z squared and then maybe a quotient. And then I think you'll be good to go. So with Z right here, you see that has a modulus bigger than 1. So when I multiply it by itself, it's going to get even bigger again. If I said this is about, I don't know, 1.5 right here, then the result of squaring it is going to be like 1.5 squared. So it's going to be around 2. That's going to be one of these dots in the outer ring. And maybe its modulus wasn't 1.5, maybe it was like 1.4, I don't know. But you see, we're going to get something definitely bigger in terms of the magnitude. And then in terms of the angle, what do I have here? Is this like, I don't know, 160 degrees? Okay, so if I multiply Z by itself, that means I add 160 to 160, and I'm going to get something around 120. Okay, so, I'm sorry, 320. So that rules out most of these, and there's only one option really left. It's that T right over there. So Z squared would be T, that dot in quadrant 4. Now, let's try a quotient. I think that'll be fun. Let's try Z divided by W. That's probably the hardest quotient one on here that I can see. If I do Z divided by W, first I like to think about the magnitudes and what's happening to the modulus of these things. So Z has a modulus of something like, I don't know, what did I say before, 1.4? About 1.4. And W has a modulus of 1. So we see that when we divide Z by W, nothing's really going to change. It's still going to be 1.4. So I'm looking at these as my options, these dots right here. The question is, and this is how we're going to determine the final answer, what happens to the angle as you divide Z by W? Well, here's what you get. You get theta Z minus theta W. Okay, so in other words, something like 160 degrees minus something that looks like 240 degrees. Okay, and that gives me negative 80, I think, and whoops, I'm not on the unit circle anymore, so maybe just add 360 to make it a little easier to see what we have here. And that's going to be equal to 280 degrees. Okay, oh, look at that. There it is right there. So that's a little past 270. That's the one I want. And we're going to go with O for our answer there. So this is the way you walk through this problem. Again, main themes are just, do you know how to multiply and divide two complex numbers? And what does that do to their angles? It either adds or subtracts.